Hello everyone, welcome back to my channel Sarada Devi Maths Classes. Today we will start exercise 9b in triangles. We have to prove that angle CAD is equal to angle BAE, that is CAD, this angle, that is equal to angle BAE, this angle. These two angles as equal. Then second one is CD is equal to BE, that we can do later. So first of all, first part of the question, in triangle DAB, that is first point. What is this angle? Angle DAB, that is 60 degree, because this is equilateral triangle. DAB is equilateral triangle. All sides are equal and each angle is 60 degree. So that 60 plus 60 plus 60 will give you 180. In triangle DAB, angle DAB, that is equal to 60 degree. Reason is equilateral triangle DAB. This is second. Now third point is in triangle CAE. Fourth point is angle CAE. Angle CAE is also 60 degree, because this is also equilateral triangle. All these sides are equal and each angle is 60 degree. So this is 60 degree. Reason is the same, equilateral triangle CAE. Fifth point we can write here, this angle DAB is equal to 60 degree and angle CAE is also 60 degree. So that means angle DAB is equal to angle CAE. So we can write angle DAB is equal to angle CAE from 2 and 4. Sixth point, we want CAD. So CAD can be obtained by adding BAC to DAB. Again DAE we want here. That can be obtained by adding DAC to angle CAE. So we can write add angle BAC to both sides of this 5. So angle DAB plus angle BAC, then that is equal to angle BAC plus angle CAE. Now seventh point, angle DAB plus angle BAC, that will give you angle DAC. So we can write that angle DAC. Now this is equal to angle BAC. Angle BAC is this, then angle CAE, that is this. So adding BAE we will get. So BAE. Now eighth point, angle DAC is the same as angle CAD. So we can arrange like this, CAD, that is equal to angle BAE. So we have arrived here. So we have proved first part of the question. Now the second part of the question is CD is equal to BE, that we have to prove. CD and BE. I am drawing another figure in the next page. So here in the second part we have to prove that CD is equal to BE. So I have joined B to E and C to D. So we have to prove that CD is equal to BE. So let us consider two triangles CAD and BAE. We can mark these two triangles with different colors. So this is triangle CAD and this is triangle BAE in blue color. So we can write the ninth point as in triangle CAD and triangle BAE. 10th point we can write this AC. AC, that is equal to AE. Why? These are the sides of this equilateral triangle ACE. So we can write the 10th point as AC is equal to AE. Reason is sides of equilateral triangle ACE. Now 11th point, this angle CAD, that is equal to angle BAE, that we have proved in the first part of this question. So we can write from 8 as 12th point, we can write this AD, that is equal to AB. So these are the sides of this triangle ABD. So we can write AD is equal to AB. Reason is sides of equilateral triangle ABD. So we got one side, this AC, then angle CAD, this angle, then AD side is this for the first triangle. Again for the second triangle, AE, this side, angle BAE, this angle, then AB is this side. So these two triangles CAD and triangle BAE become congruent. Why? Because of what test? By side angle side. So SAS test. So we can write as 13th point. Therefore triangle CAD is congruent to triangle BAE. Reason is by SAS test. So if two triangles are congruent, all their corresponding sides and angles are also congruent. So we can write as 14th point, the CD and BE are corresponding parts of these triangles CAD and BAE. So we can write CD is equal to BE. What is the reason? By CPC TC. So we have proved the second part of the question. Now the second question is, in the following diagrams, ABCD is a square and APB is an equilateral triangle. In each case, we have to prove that APD is congruent to BPC. Then second, find angles of DPC. We will take the second diagram after solving the first case. So this is the first diagram. In that ABCD is square and APB, which is equilateral triangle. First of all, we have to prove that triangle APD is congruent to triangle BPC. So we have to show that three parts of this triangle are equal. So first of all, let us take the triangles APD and BPC. So let us write first point. In triangle APD and triangle BPC, here this AP, which is equal to BP, as this is equilateral triangle, these are sides of equilateral triangle. So we can write AP, that is equal to BP. Reason is sides of equilateral triangle APB, which is given. Now third point, we can take this AD and BC. These are sides of the square ABCD. They are equal. All sides of square are equal. So we can write AD, which is equal to BC. Here this AD will come as a side of the first triangle and BC will come as a side of the second triangle. So the reason is sides of square ABCD. Fourth point, we can write angle DAB, that is equal to 90 degree. In the case of square, each angle will be 90 degree. So angle DAB is equal to 90 degree. Reason is ABCD is a square, equal length, and measurement of each angle is 60 degree. So that sum of that 60 degree plus 60 degree plus 60 degree will give you 180 degree. So we can write angle PAB, that is angle of this equilateral triangle, is equal to 60 degree. Here the reason is triangle APB is equilateral triangle, which is also given. Now sixth point we can write, therefore angle. Now we can write fifth point as, so this much measurement is 90 degree. In the case of equilateral triangle, we know angle PAB, which is 60 degree, DAP, that is 90 degree minus 60 degree. that is 30 degrees. So we can write angle DAP that is equal to angle DAB minus angle PAB that is equal to 90 degree minus 60 degree. So that will give you 30 degree. In the case of the triangle BPC also we can take like this. Angle CBA will give you 90 degree. Angle PBA that will give you 60 degree. That is angle of equilateral triangle. So what is angle CBP? That is 90 degree minus 60 degree. That will give you 30 degree. So we can write similarly angle CBP that is 30 degree. So here angle DAP is 30 degree. Angle CBP is 30 degree. So we can write angle DAP is equal to angle CBP. So we can write 8th point as therefore angle DAP that is equal to angle CBP. That is from which points 6 and 7. Now 9th point. Thus in the case of these two triangles APD and BPC, two sides AD and BC equal, then AP and BP are equal, then angle DAP is equal to angle CBP. So this side, then this angle, and this side are equal. So we can say that triangle APD is congruent to triangle BPC. By what test? By side angle side test, that is SAS test. So we can write the 9th point as therefore triangle APD which is congruent to triangle BPC. Reason is by SAS test. So the first part is okay. Now in the second part of the question it is asked to find out angles of triangle DPC. Square is ABCD. Each side will be the same. This APB is equilateral triangle. So each side of this equilateral triangle will be the same and each angle also will be 60 degree. Okay. Now on observing we can see that one side of this square that is AB which is common to this equilateral triangle APB also. So we can write AB is equal to BC is equal to CD is equal to DA is equal to AP is equal to PB. By reason is AB side is common to both square and equilateral triangle. So we can write the 10th point as in triangle APB and square ABCD. 11th point we can write AB is equal to BC is equal to CD is equal to DA is equal to AP is equal to BP. Reason is AB side is common to both square ABCD and equilateral triangle APB. Now we can take triangle BPC. So we can write 12th point as in triangle BPC. 13th point. So here all sides this AB is equal to BC is equal to CD is equal to AD is equal to AP is equal to BP. So we can mark it like this. All sides are equal. So now we can see that in triangle BPC this BP is equal to BC. BP and BC sides of this triangle BPC. BP and BC are of same length. So two sides are of same length means that is what type of triangle? That is isosceles triangle. In the case of isosceles triangle, two sides are of equal length. Then what? Then angles opposite to those two sides will be of the same measurement. So we can write 13th point as BP is equal to BC and 14th point Therefore, angle BPC is equal to angle PCB. What is the reason? Reason is angles opposite to equal sides of triangle BPC. Now we can write 15th point. Here in the case of triangle BPC, sum of angles will be 180 degree. So the 15th point is angle BPC plus angle PCB plus angle CBP, that is equal to 180 degree. That is sum of angles of triangle. That is angle sum property. Now 16th point, angle BPC plus angle PCB plus angle CBP. What is that? From point 7, angle CBP, that is 30 degree. We can substitute that here, that is equal to 180 degree. So here we can write reason as from 7. This is 7th point. So the 16th point is this. So 17th point, therefore angle BPC plus angle PCB. What is that? That is 180 degree minus 30 degree. 30 degree we can take to the right hand side. So this is equal to 150 degree. So sum of these two angles will be 150 degree. Again we know angle PCB is equal to angle BPC, that is from point 14. This is 14th point. Angle BPC is equal to angle PCB. We can substitute that there. So this is angle BPC plus, instead of this we can write angle BPC, that is equal to 150 degree. So this x plus x is 2x. Like that we have, instead of this x, angle BPC. So we can write 2 into angle BPC, that is equal to 150 degree. So what is angle BPC? Angle BPC is 150 degree divided by 2. So that is equal to 75 degree. Again we know angle BPC is the same as angle PCB. So we can write therefore angle BPC, that is equal to angle PCB, that is equal to 75 degree. As this BP is equal to BC, these angles BPC and BCP are equal. From this 18th point we got angle BPC is equal to angle PCB is equal to 75 degree. We can mark that there. So here this is 75 degree. This is also 75 degree. So as these two triangles APD and BPC are congruent, as we have proved in first case, we can see that angle ADP is equal to angle APD, and that also will be the same as 75 degree. By what? By CPC TC, because these two triangles are congruent. So we can write the 19th point as angle ADP, that is equal to angle DPA, and that is equal to 75 degree. Reason is CPC TC. Now the next point, we can take triangle DPC. So we can write in triangle DPC. It's in this triangle DPC, angle DCB, that is equal to 90 degree, this much, and angle PCB is 75 degree. So what is angle DCP? That will be 90 degree minus 75 degree, that is 15 degree. Similarly we can say that angle CDA, that is 90 degree, and this much angle DAP, that is, these two are congruent triangles, so this is also 30 degree. We have found it earlier. So these two sides equal means these two angles are of the same measurement. So what is that measurement? As in the case of this triangle, we can see the angle PDC, that is equal to what, this is 75 degree, so this also will be 15 degree. How 90 degree minus 75 degree? So we can write 21st point as angle DCP is equal to 90 degree minus 75 degree, that is 15 degree. So next point is similarly angle PDC is equal to 15 degree. So here this is 15 degree, here this is also 15 degree. That is in the triangle DPC, this angle and this angle we have to find out this angle. So what is the sum of the angles of this triangle DPC? That is 180 degree. So we can write 15 degree plus 15 degree plus this angle will give you what, 180 degree. From that we can find out this angle. So we can write angle DPC plus angle PDC plus angle PCD is equal to 180 degree. So angle DPC plus we got angle PDC as 15 degree and angle PCD or DCP as 15 degree. These two are same, so that is equal to 180 degree. So reason is from points 21 and 22, and also angle PCD is equal to angle DCP. So angle DPC plus 30 degree will give you what, 180 degree. So angle DPC is equal to 180 degree minus 30 degree, that is 150 degree. This is the second diagram. Here we have to prove that first one, triangle APD which is congruent to triangle BPC. You can write in triangle APD and triangle BPC. This is first point. Then second one, here this AD is equal to BC. Why? Because these are sides of squares ABCD. So we can write AD is equal to BC. Reason is sides of square ABCD. Now we can see PA is equal to PB. Why? Because these are sides of equilateral triangle APB. So we can write third point as PA is equal to PB. Reason is sides of equilateral triangle APB. Now we got two parts of these two triangles as equal. That is AD is equal to BC and PA is equal to PB. Now we want to get one more part. So we can take the angle PAD. What is angle PAD? That is angle BAD plus angle PAP. What is angle BAD? This is 90 degree because this is angle of this square ABCD. Again this is PAB, that is equilateral triangle. So each angle is 60 degree and all sides are of equal length. So here total angle, that is angle PAD is equal to 90 plus 60. So we can write angle PAD is equal to angle BAD plus angle PAB, that is equal to 90 degree plus 60 degree, that is equal to 150 degree. Here in this case also angle ABC plus angle PBA. Here also this is 60 degree and this is 90 degree. So the total angle PBC is 90 degree plus 60 degree, 150 degree. So we can write it directly as fifth point, angle PBC, that is equal to 90 degree plus 60 degree, that also will be 150 degree. So we can write sixth point as angle PAD is equal to angle PBC. Reason is from 4 and 5. So we got three parts as equal. This is side, and this is angle. So these two triangles APD and BPC are congruent by what is? By side, then angle, side. Angle is in between the two sides. So we can write seventh point as, therefore, a triangle APD is congruent to triangle BPC by SAS test. Now the second part of that question, eighth point. Here we have to find out the angles of triangle DPC. Here we can see that one side of equilateral triangle is AB. That is also a side of this square ABCD. That is, the side AB is common to both equilateral triangle and square. So we can say that AB is equal to BC is equal to CD is equal to DA is equal to AP is equal to PB. So we can write AB is equal to BC is equal to CD is equal to DA is equal to AP is equal to PB. The reason is side AB is common to both square ABCD and equilateral triangle APB. We can write ninth point in triangle PAD. So this is triangle PAD. Here these two sides are equal. That is, PA is equal to AD. Again, angle APD and angle ADP, they are equal. Why? Because these two sides equal means this is what type of triangle? This is isosceles triangle. Two sides are equal in a triangle means angles opposite to those two sides also will be equal. That is, base angles, that also will be equal. That is, these two angles will be equal. So we can write 10th point as PA is equal to AD. Then 11th, angle APD is equal to angle ADP. What is the reason? Reason is triangle PAD is isosceles triangle. So that is PA is equal to AD, which implies base angles same. Now 12th point. In this triangle PAD, we can see that this angle, that is angle APD plus angle ADP plus angle PAD will be what? 180 degrees. That is, sum of angles of a triangle will be 180 degree. That is angle sum property. But we know this angle, that is angle PAD, as 90 plus 60, 150. We got it earlier. So we can write that angle APD plus angle ADP plus 150 degree, that is equal to 180 degree. That is from 4. Now 13th point is angle APD plus angle ADP, that is equal to 180 degree minus 150 degree. That we will take this 150 degree to the right hand side. What is this? This is 30 degree. But we know angle APD is the same as ADP from this 11. So we can write this as angle APD plus angle APD is equal to 30 degree. What is the reason? That is from 11. Now 15th point is 2 into angle APD is equal to 30 degree, that is x plus x, that is 2x by using that. So what is angle APD? That is 30 degree by 2. So angle APD is equal to 30 degree divided by 2, that is 15 degree. But angle APD is the same as angle ADP. So we can write therefore angle ADP, that also will be what? 15 degree. So we got these two angles. We can mark those two angles here. 15 degree. This is also 15 degree base angles. In a similar way we can say that in triangle PBC, angle BPC is equal to angle BCP. What is that? 15 degree. As these two triangles are congruent. We have proved in first case this. So corresponding angles and sides will be congruent, that is equal. So we can write similarly in triangle PBC, 18th point, angle BPC is equal to angle BCP, that is equal to 15 degree. We can mark these two angles here 15 degree. This is also 15 degree. Now you consider this triangle PDC. This is the triangle. Here angle PDC. What is angle PDC? This much angle. We know the total angle, that is ADC as 90 degree, and again we know angle ADP as 15 degree. So what is angle PDC? That is angle ADC minus angle ADP, that is 90 degree minus 15 degree, that is 75 degree. We can write angle PDC is equal to 90 degree minus 15 degree, that is 75 degree. In a similar way we can write angle PCD also. What is angle PCD? That is total angle 90 degree, that minus angle BCP, that is 15 degree, that is equal to 75 degree. So we can write that. Angle PCD is equal to 90 degree minus 15 degree, that also will be 75 degree. So we got two angles in the required triangle DPC. So we can mark that in this triangle, that is angle PCD. This angle got as 75 degree. Again we got PDC as 75 degree. So in this triangle DPC, some of the angles will be angle PDC plus angle DCP plus angle CPD, that is 75 degree plus 75 degree plus angle CPD. So we can write that angle DPC, that is equal to 180 degree minus 75 degree plus 75 degree. If you want you can write one more step, that is angle DPC plus this angle PDC, that is 75 degree, plus angle PCD, that is 75 degree, that is equal to 180 degree. Then angle PDC is equal to 180 degree minus 150 degree, that is equal to 30 degree. So we can mark that in the diagram. Angle DPC, this is equal to 30 degree. So we got all angles of triangle DPC. Now third question is, in the figure given below, triangle QABC is right angled at B. Here it is 90 degree. ABPQ and ACRS are squares. To prove that, first one is ACQ. ACQ is congruent to ASB. Second one is CQ is equal to BS. So first of all, here in this case, we can take the two triangles ACQ and ASB. So we can write that in triangle ACQ and triangle ASB. Here we can see that QA, that is equal to AB. Here the side of the square is QA. That is one side of this triangle ACQ, isn't it? Again, AB, that is side of the square. That is also a side of the triangle ASB. Okay. So we can write as second point QA is equal to AB. Reason is side of square QABP. Now third point we can write this AC, that is equal to AS. Reason is side of square ACRS. Now we will arrive at angle QAC is equal to angle BAS. For that, QAB, we know this angle is 90 degree. That is angle of square. Again, for this square, angle CAS, that also is 90 degree. So we can write fourth point as angle QAB is equal to angle CAS. These two. That is equal to 90 degree. Again, in order to get this much measurement, we have to add angle BAC to this angle QAB. Again, in order to get angle BAS, we have to add angle BAC to angle CAS. So we can add angle BAC to both sides. So we can write angle QAB plus angle BAC is equal to angle BAC plus angle CAS. This. The reason we can write adding angle BAC on both sides of 5. Now sixth point we can write. So QAB plus BAC is QAC. So we can write angle QAC, that is equal to angle BAC plus angle CAS, that is angle BAS. So angle BAS. So we got these two sides, that is QA and AB as equal. Then again AC is equal to AS we got. Then angle QAC is equal to angle BAS. So we got three parts of these two triangles as equal. So we can say that these two triangles are congruent to each other by what is by this is side, angle and side. That is angle is in between these two sides. So we can write as seventh point, therefore triangle ACQ, this is congruent to triangle ASB by SAS test. Now again, these two triangles are congruent means their corresponding sides and corresponding angles are also congruent, that is they are equal. So easily we can arrive at second part of this question, that is CQ, that is one side of the first triangle, and BS, that is one side of the second triangle. So we can say that CQ is equal to BS. That is the second part of the question. By what? By CPC, TC. So 8th point is, therefore, CQ is equal to BS. Reason is CP. Now the fourth question. In a triangle ABC, PD is the median to the side AC. Again, what is given? BD is produced to E such that BD is equal to DE. So we have to produce this BD. So for this much, we have produced this up to the point E, so that this BD is equal to DE. Then what? Then we have to prove that AE is parallel to BC. Join this A and E, so that this AE and BC are parallel. That way to prove. Vertically opposite angles and interior alternate angles should come to your mind if two lines are parallel. So here we have joined this A to E. So we can write join AE, first point. Then second point we can write in triangle ADE and triangle BDC. Now third point is, here this AD is equal to DC. Why? Because BD is the median to the side AC of the triangle ABC. So we can say that AD is equal to DC. So we can write AD is equal to DC. Here AD is the side of the first triangle ADE. DC is the side of the second triangle BDC. So two sides equal. So we can write the reason as BD is median to AC. Fourth point we can write BD is equal to DE. Why? That is given in the question. So we can write given as the reason. So here this BD is one side of the triangle BDC and DE is one side of the triangle ADE. Now as fifth point we can write, therefore angle ADE and BDC. What about these angles? If two straight lines intersect, the angles opposite are vertically opposite angles. These two is also vertically opposite angles. So in that case, vertically opposite angles will be equal. So here, what about this angle ADE and BDC? These two are vertically opposite angles and are equal. Like that, this ADB and EDC also. But we have to take these two only in these two triangles. So we can write, therefore, angle ADE is equal to angle BDC. Reason is vertically opposite angles. Now as next point 6, what you can write here, one side equal, again one side equal, and one angle equal. So side, angle, side. So by what test we can write these two triangles as congruent? By SAS test. So we can write, therefore triangle ADE is congruent to triangle BDC by SAS test. So what about these two angles DAE and DCB? These two are corresponding angles of these two congruent triangles. So they are also equal. So we can write as seventh point, angle DAE is equal to angle DCB by CPCTC. But we know these two are interior alternate angles. Two parallel lines are cut by a transversal. Then these two angles will be interior alternate angles. Like that, these two angles also interior alternate angles. Here, if you consider this AC as transversal, then these two angles will be what? Interior alternate angles. We can write, but these are interior alternate angles also. So interior alternate angles means two parallel lines should be there. So BC is parallel to AE. So the ninth point is, therefore BC is parallel to AE. So we have proved QED. What are a demonstrander? That is, we have to prove. Now the fifth question. In the adjoining figure, QX and RX and RX are the bisectors of the angles Q and R. So QX and RX are bisectors respectively of the triangle PQR. If XS is perpendicular to QR and XT is perpendicular to PQ, prove that triangle XTQ is congruent to triangle XSQ. Second one, PX bisects angle P. Here, let us consider two triangles XTQ and XSQ. These two triangles. We have to prove that any three parts are equal. Then we can prove that these two triangles are congruent to each other. So what about these two angles? These two angles are equal because this QX bisects angle Q. So we can write first point in triangle XTQ and triangle XSQ. Second one, angle TQX is equal to angle XSQ. This TQX, XQS, they are equal. Reason is QX bisects angle Q. As this XT is perpendicular to PQ, we can say that angle XTQ is equal to 90 degree. That is coming in the first triangle. Again, angle XSQ, that is also 90 degree. Why? XS is perpendicular to QR. That also will be 90 degree. So we can write as third point angle XTQ, that is equal to angle XSQ, that is in the second triangle, that is equal to 90 degree. Reason is XT is perpendicular to PQ and XS is perpendicular to QR. These are given. Now the fourth point we can write, this QX side is coming as common side to this first triangle and second triangle. So we can write QX is equal to QX. What is the reason? Common side. So here one angle, then second one is also angle, then one side. So angle side. So we can say that this triangle XTQ is congruent to triangle XSQ by what test? By AAS test. So we can write as fifth point, therefore triangle XTQ is congruent to triangle XSQ by AAS test. So the first part of the answer is okay. Now the second part, that is PX bisects angle P. That is, if you draw a line joining P and X, PX, that bisects angle P. These two angles will be equal. That we have to prove. Next, now we can write a sixth point, join PX and draw a perpendicular XZ to the side PR of triangle PQR. So this is XZ. XZ is perpendicular to the side PR of this triangle PQR. Now we are going to consider these two triangles XSR. XR is a. In these two triangles, we have to show that any three sides of angles as equal. Here this angle XRS, this angle, that is equal to XR is a, this angle. Why? Because this XR bisects angle R, that is given to us. So we can write in triangle XSR and triangle XRZ. Now the eighth point, angle XRS is equal to angle XRZ. Reason is XR bisects angle R, that is given to us. Ninth point, this side XR, which is common to the triangles XSR and XRZ. So we can write XR is equal to XR. Reason is common side. 10th point, here one angle we got as equal, one side we got as equal. Now let us see this angle XSR, that is 90 degree. Here this XZ is perpendicular to PR, so angle XZR, that also will be 90 degrees. 10th point is angle XSR is equal to angle XZR, that is equal to 90 degree, that is given. And 11th point is here angle side, this angle and this side. So this side is in between these two angles. So by what test we can say that these two triangles are congruent? By ASA test. So we can write, therefore triangle XSR is congruent to triangle XRZ. Next point, as these two triangles are congruent, all their corresponding sides and corresponding angles also will be congruent. They will be equal. So this XS of this triangle is equal to XZ of this second triangle. So we can write the reason as CPC TC. So we can write the 12th point as XS is equal to XZ, reason CPC TC. Similarly, on taking these two triangles XSQ and XTQ, this triangle, we will say that this XS is equal to XT. So we can write, similarly on taking triangle XSQ and XTQ, we will show that XS is equal to XT. That implies XT is equal to XZ. Why? Here this XS is equal to XZ. Here this XS is equal to XT. So XZ is the same as XT. That is XT is the same as XZ. That is from 12 and 14. This is point 15. Now consider the triangle XTP. XTP and XZP. In these two triangles, PX, this PX is equal to PX because it is common side. Then we can write it. 16th point, in triangle XTP and triangle XZP. 17th point, PX is equal to PX. Reason is common side. 18th point is XT is equal to XZ from 15th point. XT is this, XZ is this. So we can write XT is equal to XZ, that is from 15. Now the 19th point is this angle PTX, that is 90 degree. What is angle PZX? That is also 90 degree given. So we can write angle PTX is equal to angle PZX, that is equal to 90 degree. Why? Because this XZ is perpendicular to PR and XT, which is perpendicular to PQ. That is the reason. Now the 20th point. So here in the case of these two triangles, we got three parts as equal on side and angle. But this side PX is equal to PX. This is hypotenuse. So we can say that these two triangles XTP and XZP are congruent to each other. By what test? This is RHS. Angle PTX is equal to angle PZX, that is equal to 90 degree, means this is a right angle. So we got one side, then hypotenuse and right angle. So these two triangles triangle XTP and triangle HCZP are congruent to each other by what is? By this is a right angle, then this is hypotenuse, this is one side. So RHS test. So we can write 20th point as, therefore triangle XTP which is congruent to triangle XZP by RHS test. Now the 21st point. Therefore angle TPX is equal to angle EZPX by what is? By CPC TC. We can write 21st point as, therefore angle TPX is equal to angle EZPX reason CPC TC. Now the 22nd point. If these two angles are equal means this PX bisects angle P. So we can write, therefore PX bisects angle P. So this is QED. We have proved. Now the 6th question. In the parallelogram ABCD, the angles A and C are obtuse. Obtuse means angle greater than 90 degree. Acute means angle less than 90 degree. A right angle means 90 degree. Now points X and Y are taken on the diagonal BD. So what is diagonal here? This BD. This diagonal we have to draw. Now we have to choose points X and Y on this diagonal BD. Says that the angles XAD, this angle XAD and YCB, this angle, are right angles. So these two angles are 90 degree. Then what we have to prove? We have to prove that XA is equal to YC. So here we have to take two triangles and come to the conclusion that those two triangles are congruent to each other. Then their corresponding parts will be equal. That we have to prove. So let us take two triangles, say XAD, this triangle, and YCB, this triangle. So we can write first point as, in triangle XAD and triangle YCB, second point, this AD is the same as BC. Why? What is the property of parallelogram? In a parallelogram, opposite sides are of equal length and are parallel also. So here CD and BA are opposite sides. They are of the same length and they are parallel also. Here this AD and BC also of the same length and they are parallel also. So we can say that AD is equal to BC. Reason is opposite sides of parallelogram. Now the third point is angle DAX is 90 degree. Also this angle YCB, that is also 90 degree. So we can say that angle DAX is equal to angle YCB, that is equal to 90 degree. That is given. Angle DAX is equal to angle YCB is equal to 90 degree. That reason is given. Now the fourth point we can say that angle ADX, that is equal to angle YBC. Why? Because this is a parallelogram and so opposite sides are parallel. So here the sides AB and DC are parallel and this DB is the transversal. Like this, B is parallel, CD is also parallel and BD is transversal. So that this angle and this angle, what are these angles? Interior alternate angles. Also this angle and this angle also will be interior alternate angles. So parallel lines and transversal. So it is given in the question that this is parallelogram. So these are parallels and this is transversal. So we can say that angle ADX, that is equal to angle YBC. ADX is this angle and YBC means this angle. This is transversal, these two are interior alternate angles. So we can write this as reason is interior alternate angles. Now the fifth point here, AD, this side we got, then angle DAX, this angle, then ADX, this angle we got. So angle, side, angle in this triangle. In this triangle also angle, side, angle. So we can say that therefore triangle XAD, which is congruent to triangle YCB by what is by angle, side, angle. A is a test. These two triangles are congruent to each other means all their corresponding angles and corresponding sides are also congruent, that is they are equal. Therefore we can say that XA is equal to YC because this XA and YC are the corresponding sides. So these two congruent triangles XAD and YCB. Therefore we can say that XA is equal to YC. By what is? By CPC TC. Now the seventh question. ABCD is a parallelogram. The sides AB and AD are produced to E and F respectively, says that what is the condition given? AB is equal to BE. So produce this so that this is the point E. Then AD, that is this much length, that we have to take here so that we will mark the point here as F and this is E. And we have to join this E and F like this. Then what we have to prove? Triangle BCE, this triangle which is congruent to triangle DCF, this triangle. So here in this case we have to prove that any three sides or angles of these two triangles are equal. So at first let us write first point as in triangle BEC and triangle DCF we can write AD is equal to BC and we can write AD is equal to DF. AD is equal to DF. What is the reason? That is given. We have to produce F says that AD is equal to DF. Now the fourth point, AD is equal to BC and AD is equal to DF. That is from 2 and 3. Now the fifth point we can write AB is equal to DC. By opposite sides of parallelogram ABCD. Again sixth point, AB is equal to BE. Reason is given. Now the seventh point is DC, that is equal to BE from this 5 and 6. Reason is from 5 and 6. Fourth point is BC is equal to DF. So in the case of each triangle we got two parts as equal. Now one more part we have to find out as equal. Then we can say that these two triangles are congruent to each other. So now what about this angle CDF and angle BAD? If two parallel lines are cut by a transversal, these two angles are corresponding angles. So we can say that AB is parallel to DC. This is transversal, this AF. So we can write the eighth point as angle CDF is equal to angle BAD. What is the reason? Corresponding angles. Ninth point. Now what about these angles EBC and BAD? Yes, here we are taking this AD and BC as parallel lines and this ABE as transversal. Then these two angles will be corresponding angles. So we can write ninth point as similarly angle EBC is equal to angle BAD. What is the reason? Corresponding angles. See the points 8 and 9. Here the angle CDF is equal to angle BAD, but here angle EBC is equal to angle BAD. So we can write 10th point as angle CDF is equal to angle EBC. So therefore angle CDF is equal to angle EBC. Reason is from 8 and 9. We have considered these two triangles. So in that we got this side and this side equal, then this side and this side equal, then angle this and this equal in those two triangles. So we can say that those two triangles are congruent by side angle side test, that is SAS test. So we can write, therefore triangle BEC is congruent to triangle DCF by SAS test. Here this fourth one is BC is equal to DF. AD is same, so BC is equal to DF. Therefore triangle BEC is congruent to triangle DCF by 4, 7 and 10. Now the eighth question is, in the following figures, the sides AB and BC and the median of triangle ABC are respectively equal to the sides PQ, QR and the median PS of the triangle PQR. To prove that triangle ABC and the triangle PQR are congruent. So this side is equal to this side. This AD, it is the same as PS, same length. Then this BC and QR also of the same length. AD and PS are median, means BD is equal to DC because D is the midpoint. Here QS is equal to SR because this S is the midpoint. Here we want to prove triangle ABC is congruent to triangle PQR. So at first, in spite of taking the large triangles, we are taking the smaller ones ABD and PQS. Then we will prove those two triangles are congruent, and from that we will find one angle of those two triangles as corresponding angles, and then we will prove in the case of the large triangles. So let us take the two triangles ABD and PQS. So first point, in triangle ABD and triangle PQS. Second point, AB is equal to PQ. Reason is given. Now third point is AD median, that is equal to PS median in the case of the second triangle, that is also given. Now fourth point is BC, that is equal to QR. This implies BD is equal to QS. Reason is AD and PS are medians. So we got this side AB, then AD, then BD. So three sides as equal in the case of these triangles. So the fifth point we can write, therefore triangle ABD is congruent to triangle PQS. What is the reason? By SSS test, side test. So in these two triangles we can say that this angle ABD, which is equal to angle PQS by CPC/TC. So we can write, therefore angle ABD is equal to angle PQS. Reason is CPC/TC. Seventh point. Now take triangle ABC and triangle PQR, larger triangles. In those two triangles also AB is equal to PQ. That is given. That is from 2. Ninth point, BC is equal to QR. That also is given. That is from point 4. Again, this angle ABC is equal to angle PQR. That is by CPC/TC. Therefore, triangle ABC, which is congruent to triangle PQR by SAS test. So we have proved. Ninth question is, in the following diagram, AP and BQ are equal and parallel to each other. So these lines are parallel and at the same time equal also. Then prove that first one, triangle AOP is congruent to triangle BOQ. Then second part, AB and PQ bisect each other. In the first question, we have to prove that triangle AOP is congruent to triangle BOQ. So let us take two triangles AOP and BOQ. If we can show that three corresponding parts of these two triangles are equal, these two triangles will become congruent to each other. So let us write in triangle AOP and triangle BOQ. Here this AP is equal to BQ, that is given in the question. So we can write second point as AP is equal to BQ. Reason is given. Third point we can write angle POA, this angle, that is equal to angle BOQ. Why? Because these two are vertically opposite angles. How is it formed? When two straight lines intersect, two pairs of angles will be formed like this. Then this angle and this angle will be vertically opposite angle, and this angle and this angle will be vertically opposite angles. So here this angle and this angle in our question we are taking as vertically opposite angles and they will become equal. So we can write angle POA is equal to angle BOQ. Reason is vertically opposite angles. Next point we can take here this angle OPA and this angle OQB. What about these two angles? Here it is given that AP and BQ are parallel lines. And here if you consider this PQ as transversal, then this angle and this angle will be interior alternate angles. So we can write angle OPA is equal to angle OQB. These interior alternate angles will be equal. So reason is interior alternate angles. Here this AP is parallel to BQ. Yes, here this line AB is also transversal. So here we can see this angle and this angle as interior alternate angles. But we are considering these two only now. So we got three corresponding parts of these two triangles as equal. What about this? This is side, this is angle and this is angle. So these two triangles AOP and BOQ are congruent to each other by what test? By ICSE test. So we can write fifth point. Therefore triangle AOP is congruent to triangle BOQ. Reason is ICSE test. So the first part of the question we have proved. Now we have to prove that AB and PQ bisect each other. Yes, to prove that this AB and PQ bisect each other, we need to prove that this OP, that is equal to OQ, and OA is equal to OB. As these two triangles are congruent triangles, their corresponding parts are congruent, that is equal. So we can say that this OP is equal to OQ and OA is equal to OB by what? By CPC TC. So we can write sixth point as OA is equal to OB, that is CPC TC. Then seventh point is OP is equal to OQ. There also reason is CPC TC. So clearly we can say that this AB and PQ bisect each other. So we can write AB and PQ bisect each other. So okay, thank you very much for watching the video.